Hello, everybody. Welcome to class today. Hope everybody's having a good day today. As we get started, got one little announcement as we get things kicked off in class today, and I will post this in the Blackboard announcements as just a reminder. We won't be doing a live stream next week since our usual live stream day falls on a day of fall break next week. Next Wednesday's fall break. We won't be doing a live stream, so I'll be posting a regular type video instead of having a live stream next week. But then the following week we'll pick right back up with the live streams. And also don't forget the opportunity for completing your final project at the help desk here at the college is still on the table. I haven't had any takers on that yet. If any of you are interested in that, contact me and we'll work on getting that set up for you. So today's topic that we're talking about kind of piggybacks off of last week's topic when we were talking about help desk operation. If you remember back to last week, we were talking about what the help desk is, how it kind of operates, and all that kind of fun stuff. And so this week we're talking about one of the things that you would do quite often if you worked at a help desk, and that's troubleshooting. Troubleshooting is basically the biggest skill, the biggest and best skill that you're going to have working at a computer support type of job, whether it's a help desk or tier 1 support, tier 2 support, on upward. So we're going to look at some different processes for troubleshooting today that can help you in computer repair, but this kind of stuff could also help you just in general, like life and figuring out kind of things just for everyday life. You can kind of adapt this stuff in different ways so that you can, just kind of figure stuff out for lots of different types of things. So in order to get us started today, we're going to talk about what is troubleshooting. So let's start off by defining troubleshooting. And then we're going to look at kind of what troubleshooting is and what troubleshooting isn't. And you might be kind of surprised. So when we were thinking about troubleshooting and defining troubleshooting, we got the definition of what troubleshooting kind of is as our first bullet point here. Troubleshooting is the process of defining, diagnosing, and solving technology problems. So in relation to us, when we're talking about troubleshooting in terms of computer training and support, we're talking about troubleshooting in relation to technology problems, so that's exactly what troubleshooting is. Troubleshooting is the process of defining, diagnosing, and solving technology problems. So one of the key things to kind of point out there is the defining, the diagnosing, and the solving. So there's 3 steps to this troubleshooting process: defining, diagnosing, and solving. And we can kind of we can identify those, or we can classify those in a different set of terminology by saying like identifying, understanding, and fixing. So when we're working on troubleshooting, we're working on a wide range of interpersonal skills. We're using thinking, we're using communication skills, we're using information resources, we're using different strategies and different methods for troubleshooting. So we kind of, we oftentimes might think of troubleshooting as just kind of a simple process. Like you see the computer, you figure out what's wrong, and you fix it. But what goes into that, seeing the computer, figuring out what's wrong, and then in terms fixing it, there's a lot there. In the past weeks, we've talked about, talking to the client and, kind of interpreting what they're saying and being able to get information from the client to help you kind of figure out what's going on a client's machine. and how, you kind of have to be a translator in that sort of instance. And then you can use a knowledge base that's been built by yourself and by your fellow computer support agents over time. Those are some of those information resources. We kind of discussed those a little bit last week. When you have a ticketing system, one of the things that you have with that ticketing system is that you build a knowledge base, because you're documenting the issues as they come through. And with all of that documentation comes experience and knowledge. So you're using that stuff. And there's also different strategies as to just how you troubleshoot. And we'll look at some of that in just a moment. So I have something interesting to think about here. So we're asking ourselves some questions about troubleshooting. Is troubleshooting a step-by-step process, or is troubleshooting an iterative process? And the answer to that question is yes. Troubleshooting is both. Troubleshooting is both a step-by-step process and an iterative process. And when we look at our strategies and methods for troubleshooting, we'll see how troubleshooting is a step-by-step process and an iterative process. We're following a step-by-step process to try to solve a problem. But sometimes as we're following a step-by-step process to figure out how to solve a problem, some new information is revealed to us. And that new information that's revealed to us causes us to iterate over our step-by-step process and try new things and try different things. So we can look at troubleshooting as an A to B type scenario, or we can look at troubleshooting as an iterative, trying things until something works type of scenario, but in actuality, it's both. And then we have some more questions for ourselves here. Is troubleshooting a scientific process, or is troubleshooting a creative process? And the answer again to those questions is yes. Troubleshooting is both a scientific process and a creative process. It's scientific insofar as, as you're working through a problem using a step-by-step sort of method, you're essentially using a scientific method in order to solve your problem. You're formulating a hypothesis, you're testing your hypothesis, and then, you're employing a fix based on the results of that hypothesis. But it's also kind of also in a way, it's a creative process. Sometimes the problems that you encounter are entirely brand new. And the ways that you solve those problems might require a little bit of creativity. When you think about troubleshooting network issues, especially, that's one place where creativity might come to play a lot. Because not everything's always a black and white solution. Sometimes there are multiple solutions to a problem, and in order to get the best one, you have to be a little bit creative. So let's look at troubleshooting as an iterative process for a moment. So when we're looking at what an iterative process is, we're starting off by defining it as a repetitive process. If you think about it in terms of programming, when you write a loop, you're iterating through the code. So you're repeating through the code over and over again. So when we're talking about troubleshooting as an iterative process, we're talking about troubleshooting as a repetitive process. And as we're iterating, this is where a lot of those creative processes that, when we're thinking, well, is it a scientific process or a creative process? This is where a lot of those creative processes come up. Because in dealing with iterative processes, we end up requiring a lot of flexible thinking. It's like, okay, so I was working through this problem, some new information came up, So now I have to be flexible with this. And this flexibility is going to require me to be creative in my thought. So a creative approach requires flexible thinking. You have to be kind of flexible as you're approaching a problem. Because not everything's always going to be black and white. Some, things are going to have shades of gray. Things are going to present you with new problems as you're working through them. And these new problems aren't exactly going to fit into the mold that you're used to dealing with these issues. And there are going to be several paths or several approaches to solving these problems. So what you're going to do is you're going to go through these steps. You're going to repeat steps in a loop. You're going to, try different fixes. You're going to do different things until a fruitful path is found. But now when we're saying that we're trying different things, we're trying different things with information backing us up. We're not trying different things just out of a trial and error approach. Like, oh, I'm going to throw this at the wall and see what sticks. That's not what we're doing. We have real world information that backs us up. Let me be clear on that. Listen to kind of the stuff that I've been saying before. As you're working through a scientific approach, new information comes up. And you have to kind of go back to the well and try something new. That's what we're talking about when we're talking about an iterative process. We're not just talking about, just taking everything we have and just throwing it at a problem and just maybe something works out. We might be trying different things out, but the different things that we're trying out are based on information. They're based on facts. They're based on real stuff that we've gotten from the system, from the problem, that have given us information in order to be able to make decisions on how we should handle this troubleshooting issue. Otherwise, if we do try just a hit or miss or trial and error approach to troubleshooting, we're essentially just wasting our time. Everything should kind of be data-based, information-driven in terms of, how we're thinking about solving a problem. If you're not thinking about solving a problem in the correct way, you're going to waste time, you're going to waste resources, because you're not focusing on the issues at hand. You're just kind of, taking a shotgun approach to an issue that may or may not be there. So that's what we're talking about when we're talking about an iterative process. So here we have two diagrams here that show ourselves the difference between a sequential and iterative problem-solving process. And you can see that they're very similar. And you can also see the thing that's at the head of both of these problem-solving processes are, as I was saying, collect information to clarify the problem. Everything's information-driven. Everything's data-backed, backed by data. So we see our sequential problem-solving process here just runs in a straight line. It runs in a sequence. Collect information to clarify problem, consider alternative explanations, formulate hypothesis, test hypothesis, analyze results, and you're done. Putting this into an iterative problem-solving process basically just puts this into a loop. Same thing, puts it into a loop. When you analyze the results give you new information. And this new information helps to clarify the problem even further. So sometimes our sequential problem-solving process, sometimes we can stop and analyze results. Because the results tell us it's fixed. And so in that way, our problem-solving process was sequential and it's done. But in the iterative problem-solving process, when we analyze our results and we do that testing to see, did we solve our problem? If we determine, no, we didn't solve our problem, in fact, we have these new things happen now that we tried this, or this old problem is still happening, then we have new information that helps us to clarify our problem even further, and that gives us better alternative explanations in order to help us formulate better hypotheses and create better tests. The more information that we're able to get, the better our hypotheses, the better our tests, the more likely we are to be able to actually solve the problem. Speaking of problem solving, let's talk about what problem solving just is for a minute. Problem solving is a process that moves from the current state X, which is also known as the problem state, to the goal state of Y, which is the desired state. And when we're problem solving, the problem solving process is the process that gets us from the problem state to the desired state. And so we have some objectives in problem solving that allow us to get from the problem state to the desired state, from X to Y. We want to get there quickly, we want to get there accurately, we want to get there effectively, and we want to get there efficiently. These are all things that help us promote our customer service. Remember that whole 100% customer satisfaction 100% of the time? Well, if we're able to employ our problem-solving process quickly, accurately, effectively, and efficiently, that all plays back into that whole customer service thing. Because quick, accurate, effective, efficient problem-solving is something that our customer wants. Because remember, their device is something that they need. They either need it to do work, they need it to communicate with loved ones. They have some need for this device that they're bringing in that, they're having issues with. So if your problem-solving process, if your path to get them from the problem state to the desired state is quick, accurate, effective, and efficient, if you're doing the right things and you're doing things right, quickly and accurately, then you're going to make that client happy. Now, obviously, not all the time is this possible. Sometimes you get some real stumpers. Sometimes that problem state and that desired state, they're separated by a huge chasm. So that quickly property becomes tough to get to. The accurately objective might be tough to get. Because, sometimes when we're solving problems, we're kind of lobbing hand grenades at the issue. Especially when we're dealing with certain issues. So getting it narrowed down to one specific thing might be kind of tough if there's a whole bunch of things that are wrong at once. This is what problem solving is in a nutshell. We've got some problem solving strategies that help us bridge this gap between the problem state and the desired state. And this is what they are right here. Look for a simple and obvious solution. You might have heard about Occam's razor. That's one of the things that we're doing right off the jump is we're applying Occam's razor to our problem. We're shaving away all of the extraneous, all the frivolous kind of stuff that we, are kind of extra, and we're looking for the simple and obvious solution. Because most of the time, oftentimes, the simple and obvious solution is the solution. So if you can go ahead and fix what seems simple and obvious, that's quick, that's accurate, that's effective, that's efficient, that meets all of our objectives, that gets that problem solved, and you're on to the next one. Attempt to replicate the problem. That's one thing that we do pretty much always, is try to replicate the problem. You want to see what conditions the problem occurred under. You want to try to do the same thing that the user was doing when the problem occurred. Because you want to see if it was a certain thing that was happening that caused the problem. So then you can kind of narrow down. You can get you get the more information that you need to advance that hypothesis. Get a better idea of what's going on. Get a better understanding of the problem so you can create better tests, implement better fixes, and get things done in a quicker, more efficient manner. Examine the configuration. Sometimes it might just be simply that the device is configured incorrectly. Examine that configuration. Initiate a root cause analysis. When we initiate a root cause analysis, what we're doing is we're going backwards to try to figure out kind of what caused X, Y, or Z. So it's like, okay, this did this. Well, what caused that? Okay, well, this caused that. But what caused that? So as we work our way backwards to find the root of the problem. When we find that root of the problem, we can get rid of that. We can fix that. And when we fix the root of the problem, it just creates kind of a waterfall effect down the line. Because when you eliminate that root, all the other issues that were growing from that root are eliminated with it. View a system as a group of subsystems. So, sometimes on a system, you kind of have isolated, you can kind of look at different parts as kind of being isolated. That's one of the things that you can do there. Use a module replacement strategy. Sometimes one of the best things you can do is just replace a part. Like I could probably, it's like I could probably work on, tweaking this or that and fixing this part here and maybe running a new wire from here to here. Or what I could just do is I could take and just replace this. And that would be cheaper and that would be quicker and that would be more efficient and effective. That's why you have facilities that'll do that. It's like, well, I could probably fix that. But in fixing that, it would take more time, it would take more resources, and it would just be cheaper just to replace it. And it would also get the job done. It would meet those objectives that we talked about for problem solving. Quick, accurate, efficient, effective. Apply a hypothesis testing approach, which is, your basic cyclical, iterative strategy, and restore-to-base configuration. If all else fails, reset factory settings. You can always try that. So we'll talk about some here, and I'll kind of skip through some of these for the sake of time, because we're running short on our usual 30-minute session. But one of them is that we're looking for a simple and obvious solution, with the idea that most computer problems are simple. Most computer problems are simple. The majority of computer problems are not complex. They're easy problems that have just been caused by something that's kind of happened that, is just a really simple, easy fix. A card's become unseated, some cables have become loose, it needs a reboot, it needs a software update, the software's become corrupted, so it needs to be reinstalled. Just a bunch of little simple things that happen from time to time. What we don't want to do is we don't want to spend too much time looking for an explanation for problems that rarely occur. Every now and again, you'll encounter a problem that'll just be like a glitch, and you can't replicate it, and you can't, you can't really figure it out. You can't find a simple, obvious solution for it, and it just kind of just happened one time. N equals 1. It happened once. So if we spend a lot of time trying to figure out what happened with this problem that happened one time, like it could have been, it could have been a problem that might bring up a bigger issue down the road. But if you can't replicate it, you can't see it again, it just happened one time, you can't figure it out, there's no simple, obvious solution for it. The more time that you spend trying to test and figure it out, you're just wasting resources and wasting time. You're breaking all of those objectives that we talked about earlier on, and it's not beneficial for you or your organization. So you just kind of want to let those slide. Attempt to replicate the problem. This is a big one, so we'll talk about this one for a second. Replication is the process of trying to repeat the problem in the same or a different situation or environment. So the same or a different. We want it to happen in the same kind of environment so we know what kind of situation that it happens in, or in a different situation so that we can kind of say that it's not whatever the user was doing that was causing the issue, that it was something else. It could be a problem with, like, the operating system. So if we were to be able to do a certain set of actions on one computer and then move to an entirely different computer and do the same set of actions and have the problem replicate itself, then we can know that that's probably an issue with the base operating system itself. So if the problem also appears in a different environment, or the problem is localized and only occurs in a specific environment, then that gives us more information about what's going on and how we can work to solve this problem. Because if it's in the operating system itself, there's not a whole lot that we can do. We can wait on a patch, we can give our users information. But if the problem is localized, then we can start to drill down more about what's going on and figure it out. Examine the configuration. Just looking at the configuration, we'll kind of skip past that. Root cause analysis. We'll talk about this for just a minute. And this is, I think, where we'll stop today, is with our root cause analysis. So a root cause analysis is a strategy that looks beyond the visible symptoms of a recurring problem to search for an underlying cause. This is an iterative process. And what we're doing when we're doing a root cause analysis is that we're asking a series of why questions. Why? What caused this? Why did this happen? Okay, well, if this is why this happened, why did that happen? All right, well, if that's why that happened, why did that happen? And so on and so forth. And one of the important things that I wanted to point out here is the steps to doing a root cause analysis. We have 3 steps here for doing a root cause analysis. And one of the big things that I wanted to point out here is that you should do them in writing. Identify in writing what the problem is. Describe in writing what the problem occurs, or why the problem occurs. You want to do this in writing for multiple reasons. One is so that you have documentation. As we're working with troubleshooting and working in computer support, documentation is king. As we've said before, documentation gives us that knowledge base. It helps us to understand problems as we encounter them, and it helps us to understand new problems in the future. The more we document, the more we learn, and the more that we know for the future. It also gives us a frame of reference for the next step in our root cause analysis. So as we go through the iterative process of asking our series of why questions, when we say, okay, why the next thing, we have our last thing in writing that we can refer back to. So we're not trying to remember 2 or 3 things down the line. What did I say caused that last thing again? I can't really remember now. Oh, man. My memory's failing me. You don't have to worry about that if you have it in writing. So you're identifying the problem in writing, and you're describing the problem in writing. Good documentation. And you're going back to step 1, and you're keeping on doing that until you get to the root of the problem. And as I said before, once you get to that root of the problem, hopefully you can fix the root of the problem. And then in fixing the root of the problem, you get a waterfall effect that in turn causes everything else to sort of get fixed and repair. Because the root of the problem, that root cause, has been fixed. So it takes a little bit of time to do a root cause analysis because you're sitting down and you're doing a lot of thinking and you're doing it in writing. But sometimes this is the most efficient and effective way that you can do things because you're building a knowledge base, you're building documentation, you're building a solid foundation of understanding. You're doing things sort of the right way instead of trying to kind of jump in and kind of do things halfway and figure them out as you go along. And so that's where I'm going to stop for this week. Once again, next week we won't have a live stream. I will post a video, but it won't be quite like our live streams. It'll be a little different. We'll resume with our live streams the following week after fall break. So we'll give you all a break from the live streams for fall break. I'll turn the music back on and hang out in the chat for a couple minutes in case anybody has any questions. Otherwise, send me an email if you have any questions. Thanks for joining me in the stream this week. I hope to see you all next time.